All right, so here we go again. AB Calculus students, this is our scoring video on questions 4 through 6 here of 2014. So let's go ahead and let's begin. This is our last assignment here for the week. So we've got train, we're calling it train A, and it looks like all we have is train A here, and it's going back and forth, and we've got information given in this chart here. Notice it's a chart giving us velocity, and so we're asked to answer some questions about it. First is the average acceleration. Notice that the average acceleration, we're given velocity, so the average acceleration would be the average rate of change in the velocity. So we're doing an average rate of change problem, and so we're going from 2 to 8, so the total y change is a negative 220, and the total x change is 6. But we need to see, in order to get that point, we need to see this setup, this ratio. Okay, so we either need to see this coupled with this for an answer, or this coupled with this, or just this and this. Or just this. This right here would be adequate to get us the point. But what we can't do is have just this or just this. That won't do it. The only thing, the single expression that would get it for us would be this. This would. But ideally, we would have the difference underneath. Okay, part B. Part B is worth 2 points. So we're going to have to use the IVT. So the first thing that we're going to have to do is we're going to have to establish that the velocity at 8 is negative 120, and the velocity of 5 is 40. And you could reverse those around. But so the point is, you can't get from 40 to negative 120 without crossing negative 100. Negative 100 is in between these two values here. So if somehow you establish that relationship, that it's at 40 at one point, it's at negative 120 at another point, and that negative 100 is in between those values, whether you say it with English or whether you say it like this symbolically, you get a point. Now, to actually get your conclusion point using the IVT, you must state that it's continuous and differentiable, and then you must reference the IVT, saying that there is a time between 5 to 8 where that velocity is negative 100. If you don't state IVT, you must basically say all the things that it would. You'd have to say continuous and differentiable, and you would have to say that there must be a time in between where it's velocity at 5 and it's velocity at 8 where it is negative 100, since the velocity starts at 40 and ends at negative 120, and so it must hit every single value in between at some time. You would have to state all of that, or just reference IVT. All right, then for part C, 3 points. So first, you get 1 point for a position expression. So the position expression would either be this right here, going between the equal signs, or this right here would work. Okay, got to have that for your position expression. Got to have your initial value and then adding up your integral with the correct limits of integration and the correct function. Then you get 1 point for your trapezoidal sum. Your trapezoidal sum is this right here, from here to here. You pretty much have to have it in that way. You've got to have the multiplication in there. You've got to have the multiplied by 1/2 or divided by 2, and you've got to have where you're actually summing up the bases. And then for your position at time 12, you get your negative 150. That's where you add your 300 to the total of your trapezoidal sum to get your negative 150. All right, then for part D, 3 points. So you must implicitly differentiate this Pythagorean relation. And so we see that done here. That's 2 points for correct implicit differentiation. Okay, so we need to see that done correctly. And then if you substitute incorrectly, then you get this 160 meters per minute. Or you could have it written just like this. That would work as well. You could also have it written as this: 300 times 100 plus 400 times 125, all divided by 500. Now you can't have it in this form here because it's not, but if you have the 500 underneath this, then you're okay. All right, score that out of 9, and let's move on to question 5. Question 5. got another chart, another table here with a lot of information about both f and f's derivative and g and its derivative. So they tell us that they're twice differentiable, so we know those derivative functions also have derivatives, which means they're also continuous, and we have them defined for all those real numbers. And so let's see what they ask us to do. First, they want us to find the x-coordinate of each relative minimum on the interval and justify our answers. So for relative minimum, what we're going to have to do is we have to look for where the derivative changes from positive to negative. So looking at the derivative here of f, I see that, first off, I see that it changes from negative to positive at 1. So that's where it changes from negative to positive, so that would be a relative minimum. I do check the two endpoints, but since the function, the derivative is negative, that means the function immediately starts to go down from this endpoint, which makes this a maximum, relative max, and it's going up when it gets to this one, making this one also at 3 a relative max. So our only relative minimum is at x equal to 1, and simply put, that is the only critical point where the derivative changes from negative to positive, and you have to explain that with your justification that that's where the derivative changes from negative to positive. F prime changes negative to positive. Okay, then for part B, the first point is for establishing that f prime of 1 minus f prime of negative 1 equals 0. So that's our looking at the difference there. So we have to establish that the average, in other words, the average rate of change is going to be 0. This is our average rate of change here. The key is you establish, if you have that numerator being 0, that your average rate of change is 0, you get 1 point. Then if you can actually explain, referencing the mean value theorem, then you get the other. So you have to say it's differentiable and continuous. So we have to have that continuous and differentiable. And then we can say that since the average value is the 0, the average rate of change is 0, by the mean value theorem, there must be a point between negative 1 and 1 where the actual instantaneous rate of change is 0. All right, then for C, you get 2 points if you have the correct derivative of h. That's this right here. There's some chain rule in action there. And then if you can actually plug in the values correctly and evaluate to get 1/14th, you get your third point. Okay, then for D, if we see the fundamental theorem of calculus on display here, then you get 2 points. Your fundamental theorem of calculus on display is basically knowing that when we take this integral here, we get this inside of our evaluation. And then, so if you get this to this, that gets you one of your fundamental theorem points. If then you know to evaluate, you substitute in correctly, that gets you your second. And then if you actually do all the substitution correctly and evaluate and get -6, that gets you your third. So 1 point for going from here to here, 1 point from getting from here to here, and then the third point for getting the -6. All right, score that out of 6, and we'll go to our last question. So our last question is a classic separable differential equation question. And so this one is going to be one where we have to solve for a particular solution. So first one, we have to sketch a solution curve through a slope field. Here are the key points. It must go through this point right here. It must go up after that and then come back down. Okay? After this point, it must go down below the x-axis, have a minimum value right here, turn, and come up. It doesn't necessarily have to cross over the x-axis over here. If you made it come up at an angle like that, it would still be okay. All right, that's 1 point. Part B, 1 point for your tangent line equation. So here's your tangent line equation here. Y equals 2x plus 1. Now that's after it's been been solved for y. You don't have to solve it for y so long as you get the true equation there. So for you could use, so you're using the point 0, 1. So you could easily say y minus 1 is equal to 2 times x, or 2x. That would also work. And then if you plug in correctly to get your approximation of 1.4, you get your second point. Part C, this is where the bulk of the points are. This is finding your particular solution. So to recognize it's separable and to separate the variables gets you 1 point. So getting to this line here gets you 1 point. If you do not get your variables separated, notice 0. You're done. If you don't see separated variables, you don't have to read any further. You just give yourself a big fat 0 because that's what you've earned. Just kidding, but not really. So then after you separate your variables, you do get 1 point for that. Then you have to antidifferentiate. Here's one antiderivative. That gets you one of the 2 points. Here's the other antiderivative, sine of x. That gets you the second of the 2 points. Okay. Notice if you don't have your plus c and you don't find your plus c, 3 is your max. And that's the most you can get. So you do need to have your plus c here. Now going ahead and solving for c, you substitute in. So if you substitute in the 2, the 1 for the y and the 0 for the x, and you solve, and you go ahead and you solve for c, that gets you your 5th point. And then if you actually go and use that c to give the equation right down here in terms of y, that gets you your 6th point. Okay, go ahead, score that one out of 9, score the whole thing out of 27, take a picture of your work and turn it on in. Have a great weekend, guys.